here we want to talk about composite waveforms. Composite waveforms. The basic signals that we studied so far are unit step signal, which we show with t u of t, and it is 0 for t less than 0, and it is 1 for t greater equal to 0. The next signal is a unit impulse, with delta of t, which is equal to 1 if t is equal to 0, otherwise is equal to 0. And sinusoidal signal, with the general form of v of t is equal to va cosine of omega t plus phi, and exponential signal, which is equal to va e to the power of negative t over t sub c times u of t. These are the general and basic signals, and now we want to combine these signals to generate new waveforms. The waveforms generated by combining a step function, exponential signals, and sinusoidal signals are called composite waveforms. So the signals generated by combining the step signals, exponential signals, and sinusoidal signals are called composite signals. Okay, so let's see some examples. For example, here we have this signal v of t is equal to va u of t minus va u of negative t. Okay, so va u of t, of course, is in this form. Here is va u of t. va u of negative va u of negative t is in this form. So this one is va u of t, and this one is negative va u of negative t. If we combine these two signals together, we will have a composite signal in this form. Okay, here is the composite signal for va u of t minus va u of negative t. Let's see another example. V of t is equal to 15 e to the power of minus 2000 t minus 10 times u of t. Okay, so the first thing to sketching exponential signal is to find the time constant, which is t of c. So t of c is equal to 1 over 2000. And if we apply this, if we apply t equal to t of c, v of t will be equal to for negative, not negative, will be equal to yes, the total signal will be negative, equal to negative 4.48. How did I find this? I just simply substitute t with tc. So 15e to the negative 2000 times 1 over 2000 minus 10 u of 1 over 2000. Okay, of course, u of 1 over 2000 is equal to 1 because it's greater than 0. And if we calculate this value, it should be equal to negative 4.48. Now we plot this, we sketch this signal. The minimum value of the signal at 5t will be equal to negative 10, because at 5t, this term of the signal will practically be equal to 0, and the total value of the signal will be equal to negative 10. So at t equal to 5 tc, the signal value is negative 10, and at t equal to 0, this term will be equal to 15, and 15 minus 10 is equal to 5. So at t equal to 0, v of t is equal to 5. Okay, so let's just sketch this signal. We'll start from 5, negative 10, and at 1 tc, which is 0.5 millisecond, one tc is 0.5 millisecond, the value of the signal will be equal to negative 4.48, and at 5 tc, which is 2.5, the value of the signal will be 2.5 milliseconds, and at t equal to 0, the value of the signal is 5. And so we can now sketch the signal. Okay, so this one is the signal. Okay, where did I doing this 0.5? We know that Tc is 1 over 2000, which is 0.5 milliseconds. Okay, so okay. The next example is sketching this signal. V of t is equal to sine of omega 0 t times VA e the power of negative t over tc times u of t. If we sketch this signal, first let's write this signal in this form. VA e of negative t over tc sine of omega 0 t u of t. And now we want to sketch this signal. Time, it's v of t. The maximum value of the signal at t equal to 0, of course, at t equal to 0, this term is equal to 1, and this term is equal to 1, and this term is equal to 0. So the signal starts from the 0. So let's plot this individual. Let's plot this individual signal. If we plot this individual signal, it will be like in this form. And if we multiply it by sine of omega t, we will have this signal. VA minus VA a composite signal, which is generated by combining two signals. And of course, this dashed red curve is VA e to the negative t over tc, which is multiplied by the signal, and the maximum value of the signal occurs at tc, and the maximum value, sorry, of this, not the maximum value, the maximum value of the signal here is 0.5 VA, and here is TC. The next point is 2TC, and so on. Okay, so this one is like the composite signal generated by combining these two signals. Okay, so it was the lecture on a composite signal. We will continue our lectures in the next video.